Okay, let's get into it. Today we are looking at a piece of hardware with a name that only an engineer could love. The Kramer MC3-2HAO 4K60 HDMI 2XOUT card. I mean, that's a mouthful, right?
It is. It really is. But,
Mhm.
usually when you find these components buried in a spec sheet, they're doing something really critical, something the glossy brochures just don't mention.
Totally. So for this deep dive, I think our goal is to figure out how this modular card solves that old headache of managing really high-end video while, also trying to wrangle the audio.
Exactly. How to get audio to places it doesn't normally want to go.
Right. And just so everyone's on the same page, this is a card in the literal sense. It slides into a big Kramer modular matrix switcher. It's a component, not a standalone box. So looking at the video specs first, that's always the headline. It pushes 4K at 60 hertz. But the number that really jumped out at me was the chroma subsampling, 4.4.4.
Which is crucial.
But let's be real, does that actually matter for most people? I mean, usually devices compress color data to save on bandwidth. Why do we need the full 4.4.4 here?
Oh, it matters a ton. But it really depends on what you're looking at.
Okay.
If you're watching a movie, your eye probably won't even catch the compression.
Yeah.
But imagine you're in a conference room projecting like an Excel spreadsheet.
Oh. Okay.
Standard compression makes fine text look all fuzzy, sort of washed out. 4.4.4 means zero color compression. It needs a massive 18 GB piece data rate to pull it off. But the result is that all that text, all those fine lines, are just razor sharp.
So it's less about cinematic and more about like precision and readability in a professional setting. That makes sense.
Exactly. It also has HDR10 and it's HDTV 2.2 compliant. So yeah, you're not going to get a black screen when you try to play protected content.
Right. But honestly, 4K video is kind of table stakes these days. The real reason we're talking about this card isn't the video. It's the ports sitting right next to the HDMI outputs.
The two 3.5 millimeter analog audio jacks.
Exactly. You just don't see those on an HDMI output card. And this is where that intelligent forward audio routing comes in. I get de-embedding, stripping the audio out. That's for when your projector has terrible speakers.
Right. Think of a lecture hall. You send video to the projector, but you pull the audio out through that 3.5 millimeter jack and send it to the room's actual sound system. That's pretty standard.
Okay.
But the reverse, audio embedding, that's where this card gets really clever.
This is what I wanted to dig into. You can take analog audio from a totally different source and inject it into the HDMI video stream.
Precisely. You're overriding the original audio that's on the HDMI cable.
Okay, give me a real-world scenario. When would I actually use that?
Think about a corporate presentation or a command center. You might have a video loop playing on a screen, say, some generic company background footage.
Right.
But you want the CEO's voice from a microphone to be the audio that goes with that video when you record it or send it to another room. This card lets you plug that mic mix right in, and it staples that new audio onto the video feed on the fly.
So you're basically editing the media stream live. That saves you needing a whole separate audio mixer just to combine those signals.
Exactly. It simplifies the whole equipment rack.
Yeah.
And then there's the other big audio feature, ARC, audio return channel.
ARC is usually pretty simple, though. It's just the TV sending audio back to the receiver. How is this intelligent ARC any different?
It's all about where the sound goes. Normally, ARC is just a closed loop. This card allows for what I call a U-turn.
A U-turn.
Okay, picture this. You're watching Netflix on a smart TV in a boardroom. The audio travels out of the TV, down the HDMI cable, back to this Kramer card. The card then catches that signal and routes it back out through that analog audio jack we were just talking about.
Okay, but why not just plug speakers directly into the TV?
Because then you have no real control and probably bad quality. By routing it back to the card and out to a professional amplifier, you get high-fidelity sound. But here's the kicker. Because it's ARC, the volume buttons on the TV remote still work.
Wait, really?
Yep. You're controlling a professional, rack-mounted sound system using the cheap little remote that came with the TV.
That is actually a huge quality of life feature. Nobody wants to juggle 3 remotes just to turn the volume down.
For sure.
We do have to talk about the elephant in the room, though. I'm seeing a price of around, $1,400 for this one card? That's a lot of money.
It is. It's a valid point. If you're building a home gaming setup, no, it's total overkill.
Yeah.
But you have to think about the context of a modular matrix. If you're running a facility, a stadium, a university, reliability and flexibility are worth paying for.
So you're paying for the ability to fix one specific problem without ripping out the whole system.
Exactly. If you need that specific audio embedding for just 2 rooms in a 32-room building, you just buy 2 of these cards for those slots. You don't have to upgrade the entire multi-thousand-dollar system. It allows for surgical upgrades.
That makes a lot more sense. It's about not wasting money on features you don't need everywhere.
It really highlights a shift in how we think about media. We used to see an HDMI cable as just this single pipeline. You get what you get.
A dumb pipe.
Yeah, a dumb pipe. This card proves we can treat video and audio as totally separate ingredients. We can mix them, match them, strip them, replace them, all before they even hit the screen. It turns the hardware into a traffic controller.
That's a perfect way to put it.
And it leaves us with a really interesting thought, I think. If we can so easily detach audio from video and route them wherever we want, are we getting to a point where channels don't even matter anymore? We might stop designing rooms based on where the gear is and start designing them around where the person is, with the right signal just following them automatically.
Customizing the room's reality on the fly. I like that. A fascinating look at a piece of gear most of us will never see, but might be using without even knowing it. Thanks for listening to this deep dive, and we'll catch you on the next one.